Here we have a problem about Venn diagrams and probability. I've already drawn a Venn diagram. Essentially, the C stands for people that go to the circus, M is the people that go to the museum, P is the people that go to the park. So we have 3 intersecting circles, 4 people went to all 3 places, and 12 people went to none of those 3 places. So what I want to do now is I want to have a look at some of these questions and think about how we apply the rules of probability to answer them. So the first thing is find the probability that a family went to the circus. Now, we know that in total there are 40 families, so it's out of 40. Now, it says the circus, it doesn't say the circus only, but it does say the circus in total. So we're going to count all the people that went to the circus. So it's the 2, the 7, the 3, the 4. So if we add all that, we get 16. So we know the probability that someone went to the circus is 16 out of 40. Again, we could cancel that down, or we could write it as a decimal. So the next question asks us the probability that a family went to 2 or more places. Well, 2 or more places is everything in the intersecting area. So we've got circus and museum, the museum and the park, the circus and the park, but it says clearly 2 or more places, so therefore we also need to consider the people that went to all 3. So again, we know it's out of 40 people because there were 40 people in total, and if we add 7 and 3, 4 and 6, we're going to get 20 out of 40, which again we can simplify down. Next, we're looking at the park or the circus, but not the museum. So it's important here to understand the not the museum. We cannot count anybody who did not go to the museum. So again, it's out of 40 because we're not reducing where we're going here and what we're looking at. But we're looking for the people who went to the park or the circus, or indeed both. So these 2 here, plus those 3, plus this 1 here. So in total, we've got 6 out of 40, which again you can cancel. Now, here we have another one of these, given that. Okay, now, again, I'm going to have a look at how we do this with formulae when I get back from my little break. But what I want to do here is look at what does given that mean. So, given that they also went to the circus, what does that mean? It means that they definitely went to the circus. So what we need to do is we need to work out how many people went to the circus. So it's everybody in the circus circle. So if we add that up, we've got 7 and 3, 2 and 4, which is 16. So suddenly the amount of people we're looking at reduces to just 16. Now, what is the probability that they went to the museum? Out of those 16, there's only the 7 and the 4. So if we add those, we get 11. So the probability that a randomly picked person went to the museum, given that they also went to the circus, it's 11 out of 16. Now, take a note of the next one. This is an idea of picking 2 people at random. We've had a discussion about this in class. But now the question is, 2 families are chosen at random from a group of 40 families. Find the probability that they both went to the circus. So it's both circus. Both circus. Okay, so let's have a look. What's the probability that a randomly picked person went to the circus? Well, if we have a look at question I, we know that that's 16 out of 40. And now, we're going to pick the next person. So the next person, we're going to multiply. The total number of people that went to the circus is going to reduce, as is the total number of people that we can pick from. And if we multiply those together, 16 times 15 gives us 240, and 40 times 39 is 1,560. So, in this little video, we have looked at how we look at probability with Venn diagrams, how we look at combining probability, how we look at given that questions, and also about selecting 2 or more people.